Hello there. Today we will be talking about our work on Grease Terminator, a tool that adaptively re-renders user interfaces for researchers to investigate, evaluate, and deploy interventions against digital harms. The spectrum of harms and dangers that exist in the digital world is broad and highly individual. Different harms can be perpetrated by different agents with different objectives, with or without malicious intent, or of different flow or manifestations. The distribution of digital harms is so wide and varied that it is difficult to find one single approach to tackle all of them. Hence, we are intrinsically motivated by the notion that the user interface serves as the last line of defense against many potential mobile harms, and by tackling harms at an interface level, we are in a good position to protect user cognition. There are existing app modification frameworks on mobile devices, but they encounter a few obstacles to either users or developers. Some tools require escalated privileges for interventions to take place, and this places an onus of expert knowledge or effort on the user. As the number of digital harms will scale across the internet, the current landscape presumes developers will need to develop interventions for each app instance, and that users will need to install updates for each app instance. The user is also expected to install a large number of intervention tools to cover different harms, and usually will need to stick with the choices made by the intervention developers. Developers would also need to re-implement an intervention across multiple apps if the code changes are not generalizable, and if a version change occurs and the intervention breaks, the developer will need to redevelop the intervention for that app. Surveyed modification frameworks also do not make changes to certain nested interfaces, such as images or videos within apps, and usually focus on accessible elements. The general theme around these downsides is that we need an app modification framework for mobile devices that are interface agnostic and easy to use by users and developers. Our objective with proposing the Grease Terminator framework and contributing our implementation is to enable researchers to design, prototype, and evaluate their intervention hypotheses against digital harms. The general concept of Grease Terminator is that we render graphics on an overlay layer over any active interface, including browsers, apps, videos, or any other interface in the operating system. The modifications are graphical and does not change any source code of the underlying app. End users install a client-side Android app. The app streams the device screen to an external server as a real-time image to be used as input. This server could be the user's own local desktop, or ideally the researcher's external server. The server will return a translucent image with graphical changes with respect to the device image, and is overlaid over the device screen. If an application can be decomposed into functions and interfaces, the use of overlays modifies the interface of a program to render interventions. On the server side, there are two considerations: the interventions themselves and the insertion of each intervention. Once a set of modular interventions are selected, either by an end user or the researcher or by a script detecting app state, each intervention is run in sequence, and overlays are inserted on top of each other if they are non-interfering. The interventions themselves can be developed for the use of hooks. Hooks are pre-built templates that we generalized for quicker and efficient intervention development. Hooks are used as functions or scripts that process inputs and return outputs, and researchers can extend upon them and customize their own hooks. Text hooks make use of OCR to return a set of coordinates for each character or digit in an incoming device screen image. Model hooks enable the usage of machine learning models to perform inference on any given format of inputs and outputs. Mask hooks are a frequently used hook that locates similar-looking graphics instances and can make use of different mechanisms such as contour detection and few-shot learning. In addition to the variety of input sources that could also be enhanced with other tools, researchers can also customize the output modes. In this paper, we mostly focus on the removal of information from an interface, and thus focus on censoring or occlusion, though other output modes such as highlighting or generative graphics are also feasible. One use case we thoroughly tested is the intervention of different types of GUI elements. Elements can contribute to different types of harms, such as the stories bar obstructing users from their primary task and keeping them in a continuous loop. Some mobile implementations exist, but they can be specific to individual apps and may even break when the app updates to a new version. Development for each intervention type is not scalable, as the developer would be continuously expected to inspect and make source code patches for each individual app as well as subsequent app versions. With the use of Grease Terminator, the interventions developer can focus on crafting a few generalizable rules or masks that can be used to match against in-app elements. Most of our implementations required us to take single cropped screenshots of the specific elements and matching based on contours. This allowed us to scale a few interventions across multiple apps imperceptibly for the user, but also efficiently for the developer. We also enable research into interface-agnostic content moderation, including both text and images, while also enabling the deployment of open-source models. There is a great selection of models available, but also a great barrier to deploying them for individual use cases. Grease Terminator allows for the extraction and intervention of text and images across all sub-interfaces, even if they were previously inaccessible, such as the censorship of specific frames within a user-generated video. This type of intervention is particularly helpful for users who may be prone to highly specific content harms or dangers, common topics being eating disorder content, self-harm content, hate speech, or graphic content such as weapons, gore, or nudity. For the non-uniform user, the non-standardization of platform community standard guidelines and moderation policies play a role in making the digital world a dangerous place. With easier development of models and access to multiple layers of interfaces, we hope Grease Terminator can facilitate further research into content moderation as well. In addition to the previous use cases, as we would like to contribute Grease Terminator as a general-purpose app modification framework, we wish to demonstrate that the interaction states and flow of apps can be detected and intervened as well. For this baseline intervention, we were able to detect the user's scrolling activity and darken the screen as time passes or the number of scrolls hits a limit. All in all, we are motivated by the gap in available app interventions and systemic difficulties in testing and scaling them throughout the mobile world. We built Grease Terminator so that researchers can work together to understand digital harms, design, evaluate, and eventually deploy their interventions. We hope you will join us and mine-proof the phone of the future. Thank you.